Okay, good afternoon, class. So today we're looking at function and inverse functions. Okay, so let's see what they tell us about functions and inverse functions. So we are told functions. Now you have dealt with functions before, not so? We have dealt with functions. Basically graphs, straight line graphs and those things. Okay. So we are told that the function is a relationship where a rule between two sets, your domain which is normally your x and the range which is y, where every element of the domain is assigned to one and only one element of the range. Okay? So it's important for you to understand what the function is. So here we are told that for every x value, there is a y value, and only one in this case as well. Okay, so a function is a relationship where a rule between two sets, the domain which is x and the range which is y, where every element of the domain is assigned to one and only one element of the range. Okay. So the keyword here tells us exactly what we just read now. Okay? But it just reminds us what is domain. Domain is all possible x values, and my range is all possible y values. Okay, so basically that's that. Which page is this on? Sorry? 34. So here we are told that functions can be one-to-one or many-to-one. A function can be one-to-one or many-to-one relations. We use a function or f of x notation to represent the relationship between x and y. Okay, so you guys have dealt with f of x, g of x, m of x, p of x, and so on. Not so? That is your functional notation. Then you are told that the straight line y is equal to mx plus c, or f of x is equal to ax plus p are examples of one-to-one function. Now, one-to-one, if you look at this here, this is basically our x to y. So there's one x to one y. If you say, where's the other one? Many to one, there's more than one x, but one y. That's basically what it says. That's your mapping. Okay? For example, okay, here it says, remember you have worked with functions and functional notation. This we dealt with in grade 10. Not so? We've dealt with functions and functional notation in grade 10 already. Alright, let's just carry on here. Here we are told, for example, f of x equal to y equals 2x plus 3. They didn't need to put that y there. Then f of 1 is equal to, so if I see a 1, at x I put a 1. Not so. So it's going to be 1 times 2, which is 2 plus 3 is 5. Then they want to know f of minus 3. So wherever you see a x, you put a minus 3. 2 times minus 3 is minus 6 plus 3 is negative 3. Can you see that, people? Notice that the vertical dotted line cuts the graph of f once only, indicating a one-to-one correspondence. Can you see that, people? If I take my ruler, I took a ruler, okay, and I move this ruler here, what do you notice? 1x, 1y. 1x, 1y. Can you see that, people? Even on that, the x is, I think, negative 1.5, and the y is 0 here. Can you see? Anywhere along this curve, you got 1x, 1y, 1x, 1y. Can you see that? So this makes it a 1 to 1 function. Can you see that, people? This is a 1 to 1 function. Okay. And then what line is this? What do we call this line? A? If a line goes up straight, what do we call this? A what? There's this line. What do you call a line going up straight? A y intercept. You are drawing a line here. So where you're playing a vertical line. Huh? And it goes across, it's called that? Yes. Nice. Okay. So we got the vertical line and horizontal line. So this is a vertical line. Okay. So notice that the vertical dotted line cuts the graph of f of x once only, indicating a one-to-one correspondence. Then we are told between corresponds between x and y. Okay. Let's carry on with our lives. Let's see what's happening here. The parabola, the parabola. Y is equal to x squared or g of x equal to x squared plus bx plus c are examples of many to one function. Let's get again that vertical line here. Right. So looking at that vertical line, can you see, whoops, putting the wrong thing out. Right, what do you notice here? You see there? 1x. However, for that x value, there is a sign of y value. Not so. For this x value here, we have a sign of y value as well. So, there's more than one x value here. Not so. If it's more than one, we say many. So that's a many to one. Can you see that, people? Again, using the vertical line, I determined it's a many to one. Okay, more than one x, which corresponds to one y. Yes, Michael?
So, can you please do one-to-one again?
One to one.
Yes, please.
For every x, for every one x, there's one y. For every one x, there's one y. Every one x is one y. Can you see that? Oops. What am I doing? One x, one y. One x, one y. We go over that point, one x, one y. For that point, one x, one y. For this point, one x, one y. So that is, for every one x is one y. So it's a one to one. Can you see that? For every one, there is one. However, if you look at this one here, see here? Here's one x, one y. However, on this side here, that will go across there. It will give you another x value for the same y value. Not so. That is why this is there's more than one x that will give you one y. That's why it's a many to one. Okay. Then g of 1, if you substitute 1 in, you get 2. Minus 1, you get 2. As you can see, notice that the vertical dotted line cuts the graph of g of x only once, indicating that g of x is a function. Now, there's a one way to determine if something is a function. Okay? Here we see, notice that the vertical dotted line cuts the graph of g of x once only. So, if you're looking at this line here, this is your vertical line, not so. That vertical line is cutting the graph at any given point how many times? Once. If the vertical line cuts the graph once, then the graph is said to be a function. Okay. And that is how later on we're going to determine if a given graph is a function, or a given relationship is a function. Okay, it has to cut the vertical line once. The horizontal line cuts the graph, so horizontal twice, indicating a many to one correspondence between x and y. Okay, so your vertical line tells us that there is a function, and we draw a horizontal line, a line going this way now, across. And the graph cuts more than once. It now tells you it's a many to one function. Okay. But we'll do more examples of that, don't worry. Is this your introduction here? Then we are told in this graph here, in graph of x equal to negative 4x squared is not a function because it's a one to many. So if you take again that vertical line, I think it's this one, yes? You see here what's happening here? Is it cutting the graph once?
No.
No. So is this a function? No. Okay. The graph must cut the graph at one point only. The vertical line once only. Okay, at any given point in the graph. And as you see here, what do you notice? If they ask you what would the mapping be here? It's a 1, 2. You see this is 1. So it's 1, 2, many relationship. All these are relations. But certain relations are functions. And not all functions are relations. Make sense? So there's a 1 too many. So the graph, you can see that when x is equal to -4, y is plus -1. As you can see, the points indicated there. The vertical dotted line shows that the graph cuts more than once, which means the graph is not a function. If the range of the graph is restricted, what is range, people? All possible y values. Here they say if the range is restricted, the graph will become a function. Also, if the range of the graph is restricted so that y is right. So what they're trying to tell you here is that if you look at this graph here, okay, and you restrict the graph for y is greater than or equal to 0 only, then this part of the graph is going to be drawn. Not so. Which means to say, that is what the graph can look like. The one point there is -4 and 1. Not so. That must be 0. So now take that vertical line. Would this graph cut this graph at one point only? Yes.